Alright guys, here we go, number 3. I switched sides to the right because I noticed I was kind of blocking the view with my hand. So I'm on the right side, but I'm kind of blocking the light now. Sorry, it's going to be a little bit darker. Alright, question number 3 is stated a little bit differently. It says to solve this equation where the right side is equal to 0. But if you think about it, that's exactly the same thing we've been doing basically, because we've been trying to find the zeros, right? Zeros just mean the polynomial, if we stick the number in, it's equal to 0. So really it's the same question, just phrased a little bit differently. And so we're going to answer our questions instead of as zeros, we're going to say what are the roots or what are the solutions. But otherwise it's the same. Okay, I'm going to do the same thing as always. P, what are the possible P values? Things that divide 12. So 1, 2, 3, 4, 6, and 12. And what are the possible Q values? Things that divide the coefficient of the first term, which is just 1. That means P over Q is going to be positive or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Those are the options. I'm just going to run through the gamut and check them one by one. But I can do a little spot check first. Let's see if I plug in 1, is that going to give me 0? 1 minus 9 plus 4 plus 12 is not 0. What about negative 1? 1, that'll be minus 9, minus 4, plus, oh, that is 0. Actually, let's just be thorough and check with the synthetic division. And we're going to want to check this either way because I want to know what the resulting polynomial is after I divide. Now, when I write down my synthetic division, you've got to be careful here because you notice you have an x to the 4th term, right? After that, there's no x cubed term. It skips straight to the x squared term. So what you have to do is you have to write a 0 in to hold the place of the x cubed part, and then negative 9 for the x squared term, 4 for the x term, and 12 for the regular constant term. The reason behind this is kind of like when you're writing a number. Let's say I have a number 105. You write 105, right? You don't write 15 for 105 because that's 15. You need a 0 to hold the place of the tens, right? Same idea here. I have the 0 to hold the place of the cubics, the third powers. It's actually very similar to what we did with a long division. Remember how we had all our columns lined up, right? And then we had like all the x cubed terms, all the x squared terms, all in a column straight down. Okay, anyways, let's carry this thing out. Bring the 1 down. 1 times negative 1 is negative 1. Negative 1, that's negative 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Negative 9 plus 1 is negative 8. Negative 8 times negative 1 is positive 8. 4 plus 8 is 12. And 12 times negative 1 is negative 12. If I add these together, that's 0. So sweet. Our first crack was correct. That means one of the roots is equal to negative 1. Okay, and what am I left with? I'm left with this polynomial here. That represents what I'm about to write right now. We start with a 4th degree, divided, so we should end up with a 3rd degree. This is x cubed, wrong color, x cubed minus x squared minus 8x plus 12. Okay, sweet. Alright, actually I'm going to leave these guys up here because you notice I have the same values, 12 and a 1. So I have all the same rational roots possible. And let's just carry out the same thing. I know 1 doesn't work. I just found that negative 1 works. It's possible negative 1 works again, but let's just go on to the next number because probably it's not going to repeat. I mean, sometimes it does, but let's just try the next one. Let's try 2. So bring the 1 down. That's 1. 1 times 2 is 2. Negative 1 plus 2 is positive 1. 1 times 2 is positive 2. Negative 8 plus 2 is negative 6. And negative 6 times 2 is negative 12. 12 plus negative 12 is 0. So yes, it worked. Awesome. That means we found our second root. Our second root is positive 2. Sweet. And what else do we know? We know that whatever's left over is the polynomial. So this is going to be a squared term now. X squared plus x minus 6. And once I have the quadratic just means the power is 2. I'm going to stick it straight into the quadratic equation. Don't even have to think at this point, it's just kind of routine. Alright, so x equal to negative b, which is negative 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a times c. all divided by 2a, which is 2 times 1. And from here, we're just simplifying. That's going to be -1 plus or minus the square root of 1. Oh, I'm sorry. I made a mistake here. This is supposed to be a -6. -6, yeah. So 1 minus 4 times -6 is actually plus 24. So 1 plus 24 divided by 2 times 1 is just 2. Okay, moving on. That's -1 plus or minus the square root of 25, which is nice because that's just the whole number. The square root of 25 is 5, which is -1 plus or minus 5 over 2. And finally, we'll take it into two parts. If I take the positive part first, -1 plus 5 is 4. 4 divided by 2 is equal to 2. So 2 is a double root, it seems. And then if I take the negative part, -1 minus 5 is -6. -6 divided by 2 is -3. So 2 or -3. So that means 2, 1, -1, 2, and -3. And this 2, since it appeared twice, we write this little comment here as with multiplicity 2. So -1, 2 with multiplicity 2, and -3. Those are the 4 roots. And that's it. Done.